Hello, I'm Duke. I'm a fifth-year PhD student at the University of Michigan. I will present our paper, Automated Extraction and Presentation of Data Practices in Privacy Policies. This is joint work between researchers at the University of Michigan and Samsung Research. The last author, Jongmin, was affiliated with Samsung Research prior to joining CryptoLab. Privacy policies are difficult to understand because they are long and sophisticated documents written in legal language. The figures below show the privacy policies of Facebook, Amazon, and Samsung, which comprise many pages of data practice declaration. Researchers have found that it may take more than 200 hours for an average user just to read the privacy policies he or she encounters on the web in a year. However, it is necessary to understand privacy policies because they contain statements about collection or sharing of sensitive personal information. For example, Chase Bank may collect all sorts of personal information ranging from names, email addresses, mailing addresses, social security numbers, and driver's license numbers. Furthermore, ignoring privacy policies may lead to blind consent or click-through agreements, and thus poses high privacy risks to users. For example, Enroll.me service was found to have collected and stored users' data. However, the website defended that they had already stated such data practices in the privacy policy, but most users did not take time to read and find them. Users want to understand privacy policy first, so it will be useful for them to understand the types of their information collected and shared, which are among their main concerns. The main obstacle for users is that the privacy policies are too long. So our approach is to create automated techniques that extract and present relevant information to users to have them understand privacy policies easily and fast. Generally, we create an information extraction technique that helps minimize the text the users need to read. We have two main goals. The first goal is to automatically extract data objects and data actions performed thereon from privacy policies. The second goal is to present the extracted information in an easy-to-read way. In the following example, our system, called pre-extract, highlights the data types that are collected and shared in the privacy policies in the raw text to help users understand the policy documents easily. We use four data action labels: collect, not collect, share, and not share. The collect label means the data is collected or used by the first party, while the share label means the data is collected by a third party. Two annotators label the data objects in each sentence with the four labels. To increase the annotation speed and quality, we use a semi-automated process that has four steps: pre-processing, revision of existing cross-grade annotation in OPP 115, automated correction and pre-annotation, and final review. These steps were done in sequential order for each document, and the output of the annotation pipeline is a dataset of privacy policies with file-grade annotations. In the first step of the pipeline, we created new file-grade phrase label annotations based on the existing cross-grade label text spans in the OPP 115 dataset that was created by law experts. The existing annotations created by skilled workers are useful to speed up the process, such as to determine whether a sentence contains any data correction or sharing practice or not. In particular, we selected and annotated 30 documents from the 115 online privacy process in the OPP 115 dataset. We resolved the conflicting annotations, refined labels which cover long text, and identify additional data objects that the original annotators missed. In the example below, we refine an annotation that covers a long text span into fine-grained annotations that cover short phrases describing specific data types such as information, geolocation, mobile device, and unique identifier. In the automated correction and pre-annotation step, we developed a semi-automatic process that includes automated turns for correction and pre-annotation, which are commonly used to increase the annotation speed and improve the quality of corpora. The automatized corrections has two steps to create consistently labeled text spans. First, the tools remove relative and prepositional clauses. And second, they align annotations with null chunks. In the final manual review step, after the automatized correction and pre-annotation, the annotators manually reviewed the automatically created annotations. Finally, we held a discussion to reconcile the disagreements between our label policies. The resulting dataset of fine-grained data practices contains 30 privacy policy documents, which comprise 4.1 thousand sentences and 97,000 tokens. We annotated 2.6 thousand fine-grained data practices, while the inter-annotator agreement achieves more than 98% F1 score. The statistics of the dataset are shown in the table below. The correct and shared labels have the largest number of instances, while the not correct and not shared labels have the least number of instances. We then split the whole dataset into training and validation sets. The training set contains 23 documents, or 3,035 sentences, while the validation set contains 7 documents, or 1,029 sentences. We experimented the following models for extracting data practices from privacy process. The first model is called rule-based extraction, or RBE. It is based on policy-linked, a state-of-the-art privacy process analysis technique. On the other hand, PI-extract uses a neural model based on bidirectional long short-term memory, convolutional neural network, and conditional random fit, or BRSTM, CNN, CRF for short. It uses one layer of 100-dimensional bidirectional LSTM, and we experimented 2 word embeddings configurations. The first one is 300-dimensional growth word embeddings, and the second one is 1024-dimensional contextualized birth last case word embeddings. The evaluation results show that PI-extract outperforms rule-based extraction technique, or RBE. The performance scores of the models on the 4 data action labels are shown below. PI-extract achieves 64.14% F1 score overall, which is significantly higher than 41.81% F1 score of the RBE configuration. Furthermore, the bird-based model achieves much higher F1 score compared to the model based on the growth pool embeddings. We hypothesized that the low F1 scores of the models were due to the limitation of the name entity recognition or NER model, which were designed to extract context-free name entities rather than context-dependent data objects and practices. Therefore, we test the performance of NER models to extract context-free data objects without the data actions. We derive a set of data object entities by merging all of the data action labels into a single data label. These datasets had 1,737 senses, 55.3 thousand tokens, and 1,736 entities. The corpus was then split into a training set and test set. On the test set, the bird-based neural model achieved an F1 score of 80% or 79% precision and 81% recall. This result provides support that context-free data objects can be extracted with high accuracy by the neural models, and the consistencies of the annotations on data objects in our corpus. We propose a presentation method called data practice annotation to highlight and describe the data practices extracted by pair extract in order to enhance users' understanding of privacy policies. So from the predictions of pair extract, the personal data objects are highlighted and the actions performed on the data objects are described as text annotations. Specifically, the data action labels are displayed on top of the highlighted phrases so that they do not hinder the reading flow of the users on the privacy text. And the background colors of the text and labels are different for each label. We conducted a user study to evaluate the effects of the presentation on user reading comprehension. We experiment 3 configurations: plain text, data practice annotation or DPA for short, and DPA error, which is DPA with erroneous annotations. The DPA error is used to study the impact of incorrect predictions of pair extract to users' comprehension. We hired 150 crowdsourced workers from Amazon mTalk and used 4 excerpts of privacy policies. The research questions we attempt to answer are: first, if correct data practice annotations are presented, do users understand privacy policy text better, as indicated by a higher total score? Second, if erroneous data practice annotations are presented, do users have work comprehension? And the third, if data practice annotations, which are either correct or incorrect, are presented, do users need less effort to read the policy excerpts, as indicated by shorter answering time? Our experimental results show that data practice annotation significantly improves the mean total score over the plain text configuration. The average score of the plain text version is 3.69, while the average score of the DPA version is 4.67, which is 26.6% higher than the plain text version. In the figure below, the error bars represent 95% confidence intervals. On the other hand, wrong annotations or the DPI error version significantly reduce the user's comprehension. The average total score were reduced by 15.43% compared to the plain configuration, from the 3.69 to 3.12 average score. To identify the causes of the negative impacts of incorrect annotation, we further analyze the effects of DPA error when the annotations were either omitted or contained an incorrect data action label. The results show that the effect of omission incorrectness is significant, with p-value less than 0.001. But the effect of incorrect action label annotations is not significant, with a p-value of 0.68. Further analysis shows that annotations do not significantly reduce the effort of reading the policy text, as indicated by the shorter average total answering time. The difference of average total answering time among the three configurations is not statistically significant, with a p-value of only 0.66. The DPA configuration slightly reduces the average total answering time of the plain version by 17.11%, but the difference of the answering time between the DPA error and plain configurations is non-significant. Qualitative evaluation shows that a majority of the participants with the annotated versions, both DPA and DPA error versions, found that the visual aid is very helpful. 64.2% of them considered the highlighted text very or extremely helpful, while only 9.2% considered the annotations provided no or slight help. In conclusion, we constructed a large and fine-grained set of data objects and data actions in privacy policies. We developed peer extract to extract and present data objects and actions as data practice annotations on policy text. Peer extract outperforms a state-of-the-art rule-based technique, and its data practice presentation significantly improves the user comprehensions of privacy policies. Thank you very much for your attention. I will be happy to answer questions, if any.